In this video, you're learning how to tell if a number is prime or composite. And oftentimes the question comes up first is, well, what does that mean if it's prime or if it's composite? What are we talking about here? Well, here's an example down here of prime and composite numbers. Let me make this a little bit bigger so you can see it. Okay. So they say these numbers here are prime, the ones in green, and what that means is that the other ones are composite. So if I point down to here, those, well, wait, 1's not a composite number, but 4 is, and 6 is, and 8 is, and 9 is, and 10 is. So what does it mean to be prime or composite? Well, if you look at numbers that are prime, you might notice that that they can only be divided by themselves or 1. Okay, so here's 5. You could divide 5 by 5 and get 1, or you could divide 5 by 1 and get 5, but you can't divide 5 by anything else. The opposite's true for 6. You can divide 6 by 2. You can divide 6 by 3. Okay, not just 1 and 6. Same thing with 8. 8 can be divided by 1 and 8, of course, but can also be divided by 2. And 9 can, I'm sorry, and 4. 9 can be divided by 1 and 9, of course, but also 3. And 10 can be divided by 1 and 10, but also 2 and 5. So what we mean by a composite number is it can be divided by itself and 1, but also something else. Okay? So here's the question that's going to come up. If I give you some number, is it prime or is it composite? Well, let's take a look at a list of them here. This shows the first 100 prime numbers. They're highlighted here. And I don't know, being kind of a nerd, I think this is cool. It points out here that 2 is prime because it can only be divided by 1 and 2, but none of the other numbers all the way down the column are ever going to be prime because they're also divisible by 2 down here. If you look over here at 4 is not prime, and neither is anything that's divisible by 4 that ends in 4 down here. So so you're looking over here and saying, okay, it's easy to tell some of these columns they're never going to have a prime number in them. And so down over here, 11's prime, but 21's not because it's divisible by 3 and 7. And you can see down here there's several other numbers that are divisible by, that are prime, that are in the 1 column. 1 column meaning they end in 1. Same thing with 3's and 7's and 9's. Some of them are, some of them aren't. So this one shows the first 100 numbers and which ones are prime. And so if I hand you some number and say, okay, would you please tell me, is 37 prime? Well, one option is to look back over here and say, well, here's 37 right there, and yep, it's prime. So yes. Okay, but what's going to happen when we get to bigger numbers? Well, we could always check 97. Well, if you check 97, yep, it's prime. But if you get a number that's bigger than 100, what are you going to do? Well, let's check a few. Let's check, say, 143. Let's get rid of this and check out 143. Okay. Well, the question really is, can you divide 143 by some other number? Okay. Well, let's start checking number. Can you divide by 2? Well, it doesn't end in an even number, so no. Can you divide by 3? Well, you know the test for that, right? So let's add up the digits. 1, 4, 3. Add those together, you get 8. That's not divisible by 3, so nope, it's not divisible by 3. There's no sense in checking 4 because if it was divisible by 4, it would have been divisible by 2, so forget that. How about 5? Well, it doesn't end in 5 or 0, so nope, it doesn't work. There's no sense in checking 6 because if it was divisible by 6, it would have been divisible by 2 and 3, so forget that. How about 7? Okay, and so there's a divisibility test for 7. I don't think I want to mess around with it. I think I'm just going to grab a calculator over here and try it because the divisibility test for 7 is honestly about as useful as a screen door on a submarine. So I'm just going to grab a calculator, do 143, divide it by 7, and see what I get. Okay, I don't get a whole number, so nope, not divisible by 7 either. Okay, no sense checking 8 because it would have been divisible by 2 or 4. And so no sense checking 9 because it would have been divisible by 3. No sense checking 10 because that would have been divisible by 2 and 5. But we could check 11. What's 143 divided by 11? I don't have a real nice test for divisibility by 11, so I'll just try it. Oh, you get 13. So it actually is divisible by 11. By 11 and 13. So it must be composite. Okay? So you'll notice something here, maybe, and if you didn't notice it, I'll show it to you. The numbers that I should bother testing are all prime. Okay, so instead of trying to check all the numbers, let's just test a number using prime numbers. So let's get another one here. How about the number 127? Okay, let's check 127 and see, does it divide by any of these things, or is it prime? So let's check 2 and 3 and 5 and 7, and the next prime number is 11 and 13 and 17. So let's test those and see if we get them. So clearly not divisible by 2, so no. How about 3? If you add up the digits, 1 plus 2 plus 7, you get 10. That's not divisible by 3, so no. It doesn't end in 5 or 0, so no. 127 divided by 7, let's just check that here. 127 divided by 7, that's not a whole number, so no. How about 11? 127 divided by 11. Well, if you know your multiples of 11, it doesn't work, but you can always divide here on a calculator, see what you get. No. How about 13? Okay, well, 127 divided by 13. Having calculator trouble here. Yep, that doesn't work. Well, here's the interesting question. How far should I keep going? I mean, I can look at this list of prime numbers and check 2, 3, 5, 7, 11, 13, 17, 19, 23. When do I quit? When do I get to say, okay, look, it's prime? Well, there's an interesting way to look at this. If you look and say, if it wasn't divisible by 11, then I should check and see whether it's divisible by 13. If it's not divisible by 13, then I should check 17. And if it's not divisible by 17, then I should check 19. Well, how do I know when to quit? The idea is this. If it wasn't 11 times something below 11, then maybe it was 11 times 11. Well, 11 times 11 is already 121, so we're getting close to 127. And then I checked 13 as well. Well, clearly it's not 13 times anything below there, or even 13 times 13. Well, 13 times 13 is 169. We're already over this number. So here's what I do. I check all the way up until I get to a number where if I multiply it by itself, I get something bigger than 127. So let's try another number here and see if that works. Okay, let's try 141. So I'm going to check 2, 3, 4, 5, not 4, excuse me. Okay. 2, 3, 5, 7, 11, and 13. Well, when do I get to quit? Well, here's something I know. 11 times 11 is already 121. 13 times 13 is 169. If it's not divisible by 13, I'm already over 141 here with that one, so I don't even need to keep checking. So let's just check up to 11, and if it doesn't work, then we know it's prime. So it doesn't divide by 2. Okay. Does it divide by 3? Well, 1 plus 4 plus 1 is 6. Oh, yep, it's divisible by 3, so it's composite. Okay. So let's check another one here. Let's check 437. Okay, so I'm going to have to check 2 and 3 and 5 and 7 and 11 and 13 and let's see, 17 and 19. So here's a question. When do I get to quit? Well, I happen to know that 19 times itself is 361. That's almost a 437. What about the next prime number after 19? Let's see, not 20, 21, 22, 23. So it's 23. And what is 23 times 23? So let's see here. 23 times 23, that's going to be 529. Okay, that's over 437. So I can quit when I get to 19. If it's not divisible by 19, then I know it's prime. So let's check. 2, no. Let's try 3. 4 plus 3 is 7, plus another 7 is 14, so that's not divisible by 3, so no. Clearly not divisible by 5, because it doesn't end in 5 or 0. 7, let's just check here. 437 divided by 7. And I don't get a whole number, so no. Let's check 11. 437 divided by 11. That's not a whole number either, so no. Let's check 13. 437 divided by 13 is not a whole number. Let's check 17. 437 divided by 17. And I don't get a whole number either, so I can quit. Because, wait, no, I need to check 19 as well. So let me try it, sorry. 437 divided by 19. That's 23. Look at that. So it was divisible by 19, so it must be composite. Okay, so the good news is I don't have to check forever. I don't have to check every possible number. I just check prime numbers up to where I get, when I get to a prime number whose square is bigger than this number, I get to stop. Okay, so an interesting question that will come up in some of the work you'll do is how many prime numbers are there, for instance, between, say, 1 and 50? Well, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that's it. Okay, so there's 15 of them between 1 and 50. So one of the questions you're going to be asked on a quizzes later is how many are up to 100. So I'll let you count that. All right, so I hope it gives you some ideas of how to do this thing.